Hello guys, welcome back to TechDose, and in this video we will see the partition array into two arrays to minimize the sum difference problem, which is from Leetcode number 2035. The prerequisite before watching this video is to know all about the meet in the middle algorithm. If you have any confusion or you don't know, then please watch my video on this algorithm by clicking on the I button, and the link will also be added to the description below. You can just go there and watch it. Now let's read the problem statement. In this problem, you are given an integer array nums of size 2n integers. You need to partition the nums into two arrays, each of length n, to minimize the absolute difference of the sum of the arrays. To partition nums, put each element of nums into either the first array or in the second array, like we do in the knapsack division, right? Now let's look at an example for better understanding. Let's say that our array has 4 elements, 3, 9, 7, 3. Now from this array, the given size is 2n as mentioned in the question. So you know that the array size will always be even, because even if n is odd or even, it doesn't matter. If you multiply it by 2, it will always come as even. Therefore we can equally partition an array into two parts. Now the constraint is divide the array into two arrays, each of size n, and our goal is divide it in such a way so that it will minimize the sum difference. That means if you divide the array A into, let's say, A1 and A2, then the absolute difference between the sum of both the arrays should be as low as possible, and you know that the lowest absolute value will be 0. So 0 is the most optimal answer. We cannot minimize below 0. Okay. Now just to show you an example, let's consider 3973, and then from there, if we partition it equally into two parts, A1, array A1 and array A2, then in how many ways can we possibly do it? Now if you can imagine, each of the item will have two choices. Either they will be included into A1 or they will not be included into A1. So if an item is not included into A1, if it will by default be included into A2. This is how we also solve the 0-1 knapsack problems as well, right? So each of the items have two choices, right? So if you have n number of items, you will have 2 to the power n number of choices, right? Here you have 2n number of items, so you will have 2 to the power 2n choices. Okay. Now let's take this example 3973 and see that in what ways can we divide the array into two arrays, A1 and A2. So in A1 we can choose that we will have 3 and 9, and we will have 7 and 3 in A2. Now what will be the sum value of A1 in this case? It will be 12, and for A2 it will be 10. So what is the absolute difference? It is 2. So here I have written as 2. Now we could have taken 3 in the first array and 7 in the first array, and decided to take 9 and 3 in the second array, right? And in that case you will have 10 as sum of the first array, and you will have 12 as the sum of the second array, and the absolute difference between them will again be 2. Like this you can try out all possible combinations, and you will see that these are all possible combinations for the given example. I have also mentioned all the difference on the right hand side, absolute difference between the sum of array 1 and array 2. You will find that the minimum of all these differences is equals to 2, and therefore the mean difference answer is 2 in this case, and this is what we need to return. I hope the problem statement and the goal is clear. So let's look at one possible solution. Now I will assume that you know meet in the middle algorithm, and I will give you each and every step one by one. So let's look at step number 1. This is about partitioning the array into two parts. Okay. Now if you have 2n size of the array, then definitely you will have items from 0 to 2n minus 1 index. So the first array we will just take it from 0 to n minus 1, and the second array from n to 2n minus 1. Okay. So this division is not a physical assignment, but we will just imagine it ourselves that okay, the first half is for A1 and the second half is for A2, but we will not copy and make some new arrays. We are not going to do that in this step. It is just like how you take the middle partition in the merge sort, but do not actually copy the entire partitions, right? So in this case, if you just imagine the middle portion, it is order of 1 time. Okay. Now step number 2 is, having divided the arrays, we need to find all possible sums of both the arrays, that is A1 and A2, and what we want to find is these are all possible sums of A1 and these are all possible sums of A2. That means after creating the partition we need to find the sum, like 12, 10, and this will be 6 and so on, right? Therefore let's go to step number 2. we need to find all possible sum of both the arrays and organize them according to how many elements were included to form the sum. Okay, let's look at a dry run. In this case, if you have the elements 3, 3, 9, 7 in the array, then you can assume that the first two items will be a part of array A1 and the second two elements, that means the last two elements, are the part of A2. Now in that case, if you try forming all possible sum, how do you form all possible sum? So if you have, let's say 3, 3, then you can either try to take this or not take it, right? Or you can try to not take it and take it. So in this case, you will have 2 to the power n number of choices. That means if the entire array size was 2n and this array size is n, you will have total of 2 to the power n possible sum values. So in this case, if you don't include 3 and you don't include the second 3 as well, then the sum value will be 0. But then how many elements was included in the set? It is an empty set. Okay, so if I have to make an array list, that means a list of list where the rows are actually denoting the number of items included and the columns in this case are denoting the sum values which are possible, then I will create a dynamic list of list, and there I will say that for 0 number of items included, my sum can be formed as 0. Similarly for these 3, let's say you had included the first 3 to form this 3, then a single item was included to form a sum 3. So in the row number 1, I will push 3. Now the second 3 may have been formed by including the second one but not including the first one. So in that case, again a single item was included. We got the same sum, that's fine, but then a single item was included. Similarly for forming 3, we must have included both the 3's, right? So 2 items were included which are 3, 3, and therefore in the row number 2 we will input the sum as 6. Okay. Similarly you can do for the second array, and you will see that if you don't include anyone, then your sum will be 0. But if you include one item, that's a 9, then you have included one item with sum 9, and if you include only 7, you have included one item with sum 7, and similarly if you include both of them, then you have included 2 items with the sum equals to 16. Okay, so this is step number 2. Now the third step is the last step, which is to find the min difference. I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort, and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. So now that you have formed the list of lists, that means for both the arrays A1 and A2, what you need to do is, let's assume that I want to form a set. Okay, I want to form a set, let's say S1. So if I include, let's say, k elements from A1 into S1, then how many elements can I include from the second array into S1, so that total I will have n elements? Definitely you can include n minus k elements from the second array, right? I hope you got this point. I will assume a minimum difference variable which I will try to minimize, and therefore I will initialize it to infinity value or integer maximum in the beginning. My total sum of the array in this case is 22, which is 3 plus 3 6 plus 9 15 plus 7 22. Therefore, where should I get the minimum difference equals to 0, which is the most optimal answer? I will get it as target sum equals to 1. If you have already solved the target sum problem, you will understand it very easily. If you have not solved it, then what I want to do is create a set of items where the total sum is 11. And if you can do that, the other set, which is S2, will automatically become sum equals to 11. But if you get this S1 equals to 12, then the other sum will become equals to 10, right? So why this is happening? Because let's say that if A plus B will always be equals to sum, then if you move A to the right hand side by 1 position, then B has to definitely move to the left by 1 position, and therefore by just one value change of either A or B, the gap between them will be increasing 2 times. Okay, so whatever is the min difference between A and the middle value, that means middle value in this case is our target value. This is the most optimal value, because if A is equals to middle, that means the mid sum, which is the total sum of the array by 2, then B will also be middle sum, that means total sum of the array by 2, right? and in that case only we will get the absolute difference to be equals to 0. Okay, but if that doesn't happen, if the difference between A and mid is somewhat, let's say D, then what will be the difference between A and B? When A plus B will be always equals to sum, it will be 2 times of D, right? The total difference will be 2 times of D. So that you need to keep in mind while solving the problem. Now in this case, a simple solution from this point can be, if I happen to include 0 item from the first array, then I will have 0, right? What is our target sum? Our target sum is equals to 11. So let's write our target sum should be 11, right? If I include 0 from here, then what will be the target on the other side? The target on the other side will be 11 minus 0. Therefore, the new target that we want to find is 11 only. And how many items do I want to include? Since I should always have n number of items, that means 2 items in total when I am doing this operation, and I have included 0 item from the first array, then I must include 2 items from the second array. So I have no option but to go to row number 2. Okay, and whatever number of items here I have to try with only those options. So I just have 16 in this case, and therefore the total sum is 0 plus 16, right? And what was our target sum? Our target sum was equals to 11. So how close I am to 11? So my difference between the 16 value and 11 value is equals to 5, right? So what will be the difference between the two set sums? So if first set is having a sum equals to 16 and the total sum is 22, then you know that the second set will be having a sum equals to 22 minus 16, and that will be equals to 6 only, right? So what will be the difference? It will be equals to 10, which is 16 minus 6. And you can easily find this by doing 2 times of the difference with the target sum. That means equals to 10, right? So is 10 smaller than infinity? Yes. So I can reduce it to 10, right? Now I need to repeat this for all possible operations, like for all the possibilities. So I have done this for the 0th row. Let's do for all the items of the first row. Now when I do for the first row, then I will go for 3. So my target sum is 11, and if I include 3 from one side, then how many items I have included? I have included 1 item, and the sum I got was 3. So what should be my new target on the right hand side? I should include n minus 1 item. That means n value is equals to 2 here. So I need to include 1 item from the right side, and the target sum will be 11 minus 3 because 3 was already included from one side. So this will be equals to 8. Now go to row number 1, because row number 1 means if you just include 1 item, and try to check each of the item one by one. So if you take 9, right, then how much will be the sum? The sum will be 9 plus 3, that will be equals to 12. So the sum right now is 12. What is the target sum? It is 11. So the difference value D is equals to 1. So the difference between A and B will be 2 times of D. You know that, right? Because D is the difference between A and the mid value. So the difference between A and mid will be the same as mid and B. So 2 times of D will be 2. Therefore, we have found that this difference is 2 and the previous known difference is 10. So let's update this to 2. Now if you do it with 7 as well, let's try out other possibilities too. So 7 plus 3 will be equals to 10, and your target sum was 11. So your D equals to 11 minus 10, which is 1. So 2 times of D will be equals to 2. So we already have a difference value of 2, and this is not improving it. So we will not take it, right? Now we have tried all the numbers with 1 item from the second array. Now let's look at the next item. Now you see that the next item is also the same. So we will not do it for all the same items. Okay, even if you do it, you will get the same answer. Otherwise, if you can optimize, try to optimize that. So we will not do it. Let's try to include 2 items from the first array. Now if you include 2 items from the first array with sum equals to 6, let's say, then from the second array you do not include any item, because total items can be 2 only, because n value is 2. So in this case the sum is only 0. So you will add 0 to it, which will be equals to 6, and the target sum was 11, and the difference will be equals to 5, and 2 times the difference will be 10, which is definitely much larger than 2. So we have tried all the possibilities, and the minimum difference we ended up with is 2. Therefore the answer in this case will be 2 only, right? I hope you got this. Now this solution is a 2-pointer solution, and it is not the optimal approach. If you know the meet in the middle algorithm, you know that we can sort the second array and try to do binary search. So if we sort the list of list on the second array, that means array number A2, then we can always do binary search. And how is that happening? Because what we will do is, let's see what is the target sum. It is equals to 11. Now let's again do the dry run very quickly. So I will see items we will be including is 0 and the sum is 0. So what will be the target on the right hand side? You have to include 2 items and your target sum is equals to 11. So you can simply do binary search, lower bound operation. You can read about lower bound, but what lower bound does is, if you have these many items and if you find lower bound on 2, then it will stop on the first 2, and if you do lower bound on 3, then it will stop on the first item which is larger than 3, if you do not have 3, right? And if you do lower bound on, let's say, 7 or 6, then it will stop out of bounds. So whenever you go out of bound, you have to decrease the lower bound value and bring it inside the bound, otherwise you will get segmentation fault. So you should be extra careful with that. Now in this case, if you include 0 items and you have 0 as the only sum possible, you will use a one pointer approach here, moving from left to right. For each of the item you have to iterate. That means for every row and for every column, each and every item there, you have to iterate and see and apply binary search on the right hand side. So if you pick 0, then your target sum will reduce by 11 minus 0, and that becomes 11. So if you have included 0 items, your n value being 2, you already included 0 items from the first array, then you need to include 2 minus 0, that means 2 items from the second array. So go to second number row and find out lower bound on 11, and you will see that it will stop at 16, right? It will stop at 16. Now wherever it stops, you just add the value 16 plus 0, and then you see that the sum will be 16. The difference with the target sum will be 5, and so 2 times the difference will be 10. So 10 is less than infinity, update this to 10, right? Again repeat the process. I said iterate for all the values on the left hand side. So if you have just included one number of item, then we will go for 3, and so we will be having only one number of item from the second array to add up to 2 items, right? And the target sum will be 11 minus 3, which is 8. So apply lower bound on 8 on the right hand side. So if you do that, you will stop at 9, right? You will stop at 9. So check with the values and similarly repeat the process. Like 9 plus 3 will be 12, and what is the difference with 11? It is 1. So 2 times of 1 is 2. So you will update this to 2, and likewise you repeat it for all the items. Now if you see how many items are on the left hand side, you are having 2 to the power n number of items, right? And how many items are on the left hand side? 2 to the power n number of items. Okay, so even though you are applying binary search on a list, I will assume that, let's say, all the items are in the same list, even though they are not, and so you can apply it in log of 2 to the power n base 2 number of operations. Okay, so I hope this step was clear, and this step will be all about 2 to the power n times of log of 2 to the power n, right? This will be the complexity of this approach. So this will get you to the final solution, and let's discuss about the time complexity. The first approach, where you were imagining that the array is divided into 2 partitions, it is order of 1. The second step, where we were finding all possible sum of the first part and the second part, we will be using bit masking. If you do it by recursion, it will be 2 to the power n, but if you use bit masking, it will be n times of 2 to the power n. I will show you in the code. So for both the arrays of n size each, because the entire array was of 2n size, so each of them creating all possible sum will take n into 2 to the power n plus n into 2 to the power n time. And the third step was requiring for each item on the first array, that means for the first array all possible sums, you had 2 to the power n possible sums with n items. So for each of those items on the first list of list, you have to apply binary search on the second list of list, right? And we can just assume that all the items will be in the same list, which will not be the case definitely, but still I will take the worst case scenario and just say that log of 2 to the power n is the number of operation for doing binary search on a list of size 2 to the power n. Okay, so if you combine this all, will it run within 1 second, or will this give me an optimal time complexity that I can be confident it will always work? Let's see a proof for that. In the constraint section of the problem, it was mentioned that n is less than equals to 15. So the runtime operations will be one operation for partitioning the array, n into 2 to the power n, and 2 times of that. That means what is the value of n? Maximum value is 15. So 15 into 2 to the power of 15 plus the same thing plus the time complexity for the last step, which is 2 to the power of 15 log of 2 to the power of 15, and the base is 2 because you are doing binary search, right? Partitioning into two parts. So if I just ignore this one because this is just insignificant in this calculation, you will see that I can take 2 to the power 15 as common, and I can just write it as 15 plus 15, which is 30 times of 2 to the power 15. And on the right hand side we can write it as 15, which is coming from this log value, into 2 to the power of 15, right? Because you know that log a base a to the power of b will be equals to b, right? With this property we can write it like this. And then we can again take common 2 to the power of 15, and it will be 45 times of 2 to the power of 15. If you break it up, 2 to the power 15 will be 2 to the power 5 into 2 to the power of 10. So this is 32 times of 2 to the power 10, and 45 comes from here. I'm just approximating the values. I'm just taking a little bit higher value only. So this is 1600 into 10 to the power of 3, and that makes it 1.6 into 10 to the power of 6. Fine. And we will assume that 10 to the power 8 operations is 1 second. So definitely this is going to run within 1 second. I hope this entire explanation of the algorithm and the time complexity proof was very clear to you. Let's now look at the code. In the code section we are given the nums array, and I am finding the value of n, which is equals to the size of array by 2. Now this is the total sum of the array. I will be dividing the array into two parts. So you can either do this step or you can directly solve it, but just for the simplicity of understanding I have divided it into two parts. So into nums1 and nums2. After that, find all possible sum from nums1 and store it in sum1. And sum1 is actually list of list, which is running from 0 to n, and therefore you will have n plus 1 number of rows. And similarly sum2 is a list of list running from 0 to n, and so it has n plus 1 number of rows, right? It is a list of list. Okay. Now applying the bit masking approach, you can create all possible sum. You know that you have 2 to the power n number of combinations when you have n number of items, right? Because each item will have two choices. So following that, we will be finding for each of the case what will be the sum and how many items are included by simply counting how many set bits are there, right? So simply you push all the items depending on how many count of set bits are there, because those many items are present. So I will be pushing the items to their corresponding row number. Okay, and after all possible sums have been found, then we need to sort only the second array. You can also sort the first array, but that is not required because we are iterating for every item from the first list of list. So the first list of list, that is sum1, need not be sorted. But since we will be applying binary search only on sum2, therefore sum2 must be sorted. So going to each of the row and sorting them is important only for sum2. And once you have done that, then I will assign a min difference variable where I will try to minimize the difference of the entire sum of the two sets, and then I will be iterating for all the values from the first list. From the first list of list, I will be using a simple iterator, iterate through all the values, and then on the second list I will be making binary search calculation, that is using lower bound. So you can see this code for the lower bound which I have already written, and I think if you have seen my explanation on the meet in the middle, then you will find this to be the same. Okay, so I hope you will go through it, and finally we will return the minimum difference after doing the lower bound operation. Okay, so this was the entire explanation of this code. This was very interesting, and I hope you have understood the entire thing. Please comment below to ask any question, and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.